Hello everyone, the problem we're looking at today is the USACO 2019 January contest Platinum Problem 1 of Redistricting. Yup, we're going to Platinum, guys. Okay, anyways, the problem statement is actually really real life. If you know what gerrymandering is, if you've taken AP Human Geography, this problem is basically about cows doing gerrymandering. So you can pause the video first and read the problem yourself if you haven't already. So basically you have a city of cows, and then H is a type of cow, G is another type of cow. You can just think of it like Democrats and Republicans, and then you have this whole city is on a one-dimensional string, and then you're trying to redistrict the city into electoral districts, basically, and then you're trying to output the minimum possible number of districts in which there's more G than H, or there's the same number of G's than H, and each district can contain at most K cows. So, for example, if you have those two as a district, then that will contribute 1 to the answer because there's an equal number of H and G, so that's a tied district. And however, you have this as a district, then that will not result in a contribution to the answer because it's not a tied district or a Guernsey majority. I don't know how to pronounce that cow name yet, but yeah, it's not a Guernsey majority or tied because there's 2H. So now you can pause the video once again and think about how to solve this yourself. I would say for Platinum, this problem is not too difficult. Okay, anyways, first of all, this problem, despite being very real life and gerrymandering and stuff, it gives off a really strong DP vibe, right? So that's the first thing I tried, DP. Dynamic programming, FI means the number of districts as far as the I spot in which are tied or Guernsey majority. So, hold up, here's my code. Excuse me. So FI equals number of in which, right? And then this will result in a DP state transfer time complexity of obviously too big because you need to enumerate where you basically last redistrict. Anyways, actually, I'm just gonna pull up my Logo solutions and translate it because I wrote a solution on this online judge. However, it's all in Chinese, so hold on. English. There we go. Okay. So this is the original DP formula. Fi equals min, not my, min, of fj plus the difference between us. So say we break at j, this is fi. Okay, actually, for the formula, just read it in Chinese. Okay, fi equals the minimum value of out of all j, fj plus whether the difference between the number of Guernsey and Holstein in I is less than or equal to the difference between Guernsey, Holstein, and J, right? Because if the difference increased between I and J, that means we probably got more Guernsey than Holstein, so we have to add 1 to FJ. So this whole thing looks like it cannot really be optimized into a difficulty of better than O(n) squared, right? However, it actually can, because even though this term, we cannot use any data structures that really maintain it, it only at most costs 1 contribution to the answer to affect Fi. So actually, we can still use kind of like a whatever data structure you prefer to just maintain the minimum Fj. And then for those tied ones, that's where this term come into play. So in my case, I use the monotone queue or binary heap priority queue, and then wait, hold on. Okay, the translation is messing up. Okay, I just use the binary heap or a priority queue of C++, and then yeah, the code is really fast. You just gotta push in the F into the priority queue every single time, and you just pop out the smallest one. And since it's all tied, if the top one is okay, let me just pull up my code here. So essentially, the main idea is you still use a priority queue to maintain it just like any other DP. However, since this time there's one more term that can cost an almost 1 contribution to the answer, you add that contribution after you're done because it costs at most 1. So you cannot really make one that was better than another one, worse than another one. They can only make one that was tied. Now they're not tied anymore, right? So we basically use F as the first key and then the difference as the second key to sorting when in the priority queue, right? Because we know only when the first key is different do we really consider the second key, which is the difference, because that can cost at most 1, if you understood what I just yapped for all of that. So anyways, hopefully after this video, you know how to solve the USACO 2019 January contest Platinum Problem 1 of redistricting. I will have my logo solution link in the comments below along with my code, and I strongly suggest you check both of those out. And give a like to both this video and the post, because I really need a bunch of likes in the post. Anyways, thank you for watching, and I'll see you tomorrow. Okay, so that was a promo review of Instagram Court. Okay, so as you guys can see, I did not record a video yesterday because I was busy doing other stuff. But anyways, yeah, I had time for a lot of stuff, but I also had to pack because I'm going back to China like tomorrow. So I did one problem today. It's the template for radix sort, because I know radix sort sounds like it's a very complicated and advanced algorithm. Well, I mean it is, but it's just a template. So it took me like 10 minutes really. So that's all I grinded today. And since I didn't make a video yesterday, I suppose I'll do that for yesterday as well. Yesterday I did this problem. Oh yeah. I did the XOR linear basis algorithm, and I also started writing a solution for the XOR linear basis template problem on Logu. However, I did not finish because I'm a procrastinator. So yeah, that's my report for today, and I'm going back to China tomorrow, so I might not be able to post a video every single day anymore for this summer break, but I'll just try my best. Okay, thank you very much for watching for this far, and I'll see you sometimes.